Hello, today is June 22nd, 2024. We're going to continue about the electromagnetism discussion. And then today we're going to be talking about electric potential. Notice previously we talked about the potential energy, right? So let's say we try to find the work done by electrical force from point A to point B, moving slowly, and then that equal to the potential energy at A to the potential energy of the B. And then that's also equal to the negative potential B energy, potential energy A, that's negative U. Okay. Then potential versus potential energy. So those two are different concepts, even though they are related. What's the relationship? The relationship is the following. The potential, we use the V to represent, that equal to the potential energy, as what we mentioned previously. That's the letter U divided by Q naught, where Q naught is the testing charge. Okay. In other words, the potential is independent of the testing charge. Why? Because we divided by Q naught, right? And then another way we can view this is the potential is the potential energy per unit charge. Okay, that's another way to understand this. Notice when we're talking about the potential energy U, if it's the point charge, then the magnitude of that would be Q source, Q testing charge over R. Again, the potential would be U divided by Q naught. So if this one divided by Q naught, then this part is gone. So what we have is QS R. In other words, potential only matters with the original source. Okay, let's see. So let's give you an example. For instance, we have 2-point charge. One is positive QS, another one is negative QS, and then we try to find this point right here, P. We want to look at the potential at this specific point. So how do we do that? We need to connect those two, and then let's say this is a A, this is a B, this is a, let's just say AO equal to L1, which is the length from here to here. So OB, which is length from here to here, that is L2. And then from P, draw a line perpendicular to AB, that is H. So PO equal to H. Again, AP is R1, and then based on the Pythagoras theorem, so that would be square root of L1 square plus H squared, right? Because this forms right rectangular. right triangle. And then similarly, BP is this 9 segment right here that equal to R2, which based on the Pythagorean theorem again will be L2 square plus H square. Okay, so we know R1, R2. Then the potential due to Q, positive QS, will be K times, which is this formula right here. Positive QS R1, which is K QS. R1 is this value right here. It's L1 square plus H square. V2 will be equal to K due to this charge QS, which is negative QS, right? Over R2, that would be negative K QS L1 square, L2 square plus H square. Now the total V, the total potential, will be the superposition of the potential due to this charge plus the potential due to this charge. So it's going to be V1 plus V2. That is going to equal K QS L1 square plus H square, which is this guy right here, plus this. Since this is a negative value, it's going to be subtract QS L1, L2 square plus H square. Okay. So that's the discussion about potentials. Notice the force, the electrical force due to the two charge, right? This is a little bit review. Will be K Q1 Q2 all squared, right? And then F times D, which is the work, right? Associated with the work, and then also associated with the potential energy, right? So if D is one of the R, then that would be what, K Q1 Q2 R squared times R will be K Q1 Q2 R. So that is associated with the work, right, or energy. So again, this is not the regular derived, but this is just kind of let you to understand the formula or help you to memorize the formula. And then the potential is going to be the energy divided by Q naught. In this case, it's either Q1 or Q2, right? So if you look at this formula, V is going to be K Q1, for instance, because another Q is being divided by that. It's gone. And then let me see. I think that's pretty much it. And then the only thing left is the electric field E. I left this as the exercise. So you will find the relationship between E and the work, the potential, and also the potential energy. Okay, so that's pretty much it, and I will continue the discussion next time. Thank you for watching my videos. Hopefully that helps you a little bit. Thank you. See you next time. Bye bye.